Hello Math 8 students, this is dilations without a grid. We're going to show how we can do dilations, identify scale factor, find centers, even when we don't have a grid to count how big these things are or how much they're changing. So in this first problem, I've got three stars and they are all dilations of one another. How can we even find the center of dilation? We're going to start there. Will you discuss at your tables? We've done this before. Let's just put it into words. How can I find the center of dilation? Talk at your tables. Ready, set, go. Okay, and hopefully what you discussed is all of these corresponding parts are all going to line up and they're all going to intersect at that center. So I'm going to take my straight edge, my ruler. For me, I've got a straight line tool. And I'm going to connect this point with this one, because if it continues to shrink down, it's going to go here. And if it continues to shrink down, it's going to go here. And I continue just drawing that line, imagining that it's going to continue shrinking, 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 shrinking. And I can repeat that with all points. It'll be kind of crazy if I do it with all points on this one, so I'll maybe just pick another one or two. I'll do it with this one here. This is that left lower tip of the star. And it's going to shrink down to be this point. If it continues to shrink down, it's going to become this point in figure A. And if it continues shrinking down, 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 it's going to land somewhere over here. And now I can already see that these points are intersecting, or these lines are intersecting at this single point. That is the center of dilation. And if I continue to do this with multiple other points, this part of the star will shrink down to that one, down to A, and it continues to shrink down, and all of these are going to shrink down to that same single point. No matter which ones I choose to connect. Oh, this is weird about this program. It always does that. I won't do that one. They're all going to intersect at that point, so that's how we find that center of dilation. Let's make sure we write that down. Connect corresponding points with the line. Where all the lines meet is the center. All right, and now let's imagine that B is the center of dilation. Excuse me, B is the original figure. And if B is the original figure, what is the scale factor that would take B to C? We can see that it's getting bigger going from B to C. What do you think that scale factor could be? Additionally, B to A is getting smaller. So what could that scale factor be taking us from B to A? I'm going to pause the recording as students discuss. Ready, set, go. All right, what are some estimates that you guys came up with? Angelo? If I was going from A to B, it might be double, but what if I'm going from B to A? B is the original one. So if this is doubled going this way, what would that mean going in reverse? Probably 1/2. Okay. I'm going to write that down. I don't know if it's accurate, but it's a good estimate. Let's say it's about 1/2. Definitely got smaller. Is it half the size? We'll see. What's your estimate for B to C? Ike. 1.5? Okay. Now, here's how we can use our tools to actually confirm this. I like just using an index card. You can always use rulers. I don't always like to use rulers unless I absolutely need to. An index card or a scratch piece of paper will work just fine. So here's what I'm going to do. I'm going to measure a piece of the star. So I might line up my index card to measure this, like how wide that star is. So I've set my index card up on one edge and I've marked where it ends on the index card. And now I'm going to move that over here and see about how many times can I do that. Could I do that 2 times? Is it this star C, is it big enough to go across twice? No. So what do you think about that estimate of 1.5? Looks like it's 1 and then about half that same distance. So yeah, I think 1.5 is a pretty good estimate. And I can do the same thing here. This is how wide it is. Let's compare that to how wide it is right here. And how many of those do you think it would take? Looks like this star is about half of the width of the other star. So yeah, I think that 1/2 is a pretty good estimate. Okay, so that's how we would use our index card and use those tools. Now let's move on to the next problem. In number 2, we're actually going to be doing dilations. In 2 and 3, we're going to be doing dilations. So in the first one, it says dilate with scale factor of 2 and point H as that center of dilation. So if H is the center of dilation, that means everything is going to grow out from H or shrink all the way back into H. So the first thing I always do on all of these problems, when I have to do that dilation myself, I draw those lines. So I'm going to be drawing the line that goes from H, which is the center, oh, that's not the line tool, through D and beyond. Because I know that that means D, when it grows, is going to grow and land somewhere on that line. So from the center, which is H, through D and beyond. From the center, which is H, through E and beyond. E, when it grows, is going to land somewhere on this line. So we have to draw those lines so that we know where it's going to be. H through F, and I continue drawing it because F is going to land somewhere on that line. And H through G and beyond. We ready? So that means D is going to land somewhere on this line, but where exactly is it going to land? That's why we want to use our index card. You can use a ruler, and I do have a ruler set up here. What we could do is we could measure how far it is to go from H to E with the ruler. And then with the scale factor of 2, we could double that. So it looks like that is a width of like 3.4. 3.4 doubled is going to be 6.8. So it should be right here. But I want to show you the way that I prefer to do this. I prefer not to use a ruler if I don't have to. Again, I like that index card. So the way I'll use the index card is very similar to what I did the last time. I'm going to line that up, H to E, and I can see that H to E goes to here. So the edge, the corner, all the way to here, that's how long that distance is. And with that scale factor of 2, that means it's going to be this distance and a second time. And it looks like both ways I ended up about that same spot, so pretty good no matter which way you decide to do it. Let's mark that point. And that point is going to be called E prime because E grew to become this point, E prime. Do you have any questions? Okay, let's continue drawing that. We need to place all of these points. I know where E is. Now let's find out where D is. So using my index card, that means I'm going to make a mark to show how long H to D is. And once I know how long H to D is, I can move that and see how long H to D would be a second time. Repeating that again for each of those points. H to F. H to F had that same distance as H to E, so that makes that nice and easy. There's 1 and 2. And H to G there's H to D and H to G have that same length, so moving it down a second time, and there's G prime. Now what about H? Is H going to be moving at all? No, that's where everything is expanding from. So if H expands from H, it's going to still be H. So I've got all of the points. Now it's just time to draw that figure. H to D prime, D prime to E prime, E prime to F prime, F prime to G prime, and H to G prime. Pretty straightforward, pretty simple. Do you have any questions for me? Go ahead and pause the recording if you need any additional time. We're going to do part B now, which is dilating with the scale factor of 1/2, and point F is the center. So let's find point F now. That's right here. That means everything is going to expand or contract to F. I've changed the center of dilation, so I can't use these lines that I already drew the first time, because now everything is going to expand and contract from F. So I'm going to redo those lines. I'm going to do them in a different color this time. Going from F to E. This time I don't need to go beyond, because it's actually getting smaller, so I know the E is not going to land outside of that figure. It's actually going to land somewhere in here on this line. F to D. Again, I don't need to expand it and draw any further out, because with the scale factor of 1/2 it's shrinking, so it's actually going to lie somewhere within that figure. F to H, no need to go beyond, and F to G. So each of those points is now going to land somewhere on those lines. And now with my index card, the way we do it when we have to scale down is a little bit different. Not too different, but we have to understand how I can use these materials to show 1/2. So one option is I can still use my ruler and measure in centimeters, and I can see that that's, let's see, from F to G, I have a distance of about 2.1, 2-ish, depends on how precise I'm being, and I could use my calculator to cut that in half. And 2.1 is going to be cut in half to be about 1.05, so right there. But if I'm using my other tools, if I'm using my index card, I would still take this and I would measure how far that distance is. And this is the part where technology doesn't really help. If I want to cut it in half, all you have to do is fold it in half. And then when you fold it in half, wherever that fold ends, so you're going to fold this one right here so that it meets up here, and wherever that new edge is, that's going to be your halfway mark. Well, we repeat that with each of those points. So if I'm going from F to E, I'll measure that distance, and now I will fold it in half, and it looks like it's going to be right about here. Repeat that with each, F to H, measuring that distance. F to H, but now I would have to fold it in half with H meeting all the way up here at F. And I have to eyeball this because this is technology that's not going to work perfectly, but I'm going to guess that it's right here. And folding in half after I measure D to F. Fold it in half, I'm going to guess that it's right around here. Now that I've got my points, I'm going to try and create my figure. E double prime to D double prime to H prime to G double prime to F and back to E double prime. I'll give you a second to finish. I'm going to pause the recording as students finish this up in class. You can pause the recording now here as well if you need more time. For me, with my technological tools, this one was more of an estimate. With your tools, it was probably a little bit more precise, but I want to show you a great way that I can confirm that I have done it correctly. When we do a dilation, lines will either expand or shrink down to be the same line, or expand or shrink down to be a line that is parallel. Here's what I mean. Will you guys take a look at GF from the original figure? When it expanded, it became G prime F prime. Do you see how those lines, I can just pick one up and line them up because they're at the same angle. With my technology, I can show that. Just like I can see D prime and E prime is parallel to DE. They're at that same angle to one another. And so one thing that I can do when I'm checking, since this was so much an estimate, does my HD in the small figure look like it's parallel to HD prime, or this HD? Yeah, it looks like it. Is it always maybe going to be perfect? But it probably not, but it should be pretty close. Do these ones look parallel? Those ones maybe look a tiny bit off, so that might be an indication that I should maybe fix that angle just a little bit. Okay, so that's a great way to visually inspect, are the lines that we created parallel to the original figure, or at least the same line, and they should be if we're doing this correctly. Okay, what questions do you have for me? Okay, let's move on to the next one. This is the last one that we're going to do in class, and the rest is going to be up to you on your own. Still pretty simple, but what's happening in this one is now we're choosing a center of dilation that's not part of the figure. The center of dilation is all the way over here. But it doesn't change how I get started with these problems. I'm still going to draw those lines. And those lines are going to go from the center through the vertex. I am going to go beyond because I can see in part C, it's labeled. In the first one that we need to do, we're going to go a scale factor of 2. So I am going to go beyond that. From the center through this point. My technology is being kind of weird. From the center to this point, and from the center to this point. Okay, now we know our points are going to land somewhere on those lines. Now it's time to use our tools and figure out where exactly. So the first one, dilating with scale factor of 2. Again, you can use your ruler. You can measure how far away it is in centimeters, or you can use your index card. So I'm going to use my index card to see from the center of dilation to this point, it goes to here. So now once I have that measured and marked, a scale factor of 2 means it goes 1 and 2 times. So there is that mark there. And continue repeating that process, always measuring from the center through each one of those points. One and 2. Uh-oh, my index card isn't big enough on this one. All right, now I've got all of my points placed, making those measurements with my index card, moving my index card over, and now I'm going to draw that figure in place. Any questions? Again, pause the recording if you need additional time. Students in class are ready to move on, and so we are going to just repeat that process, folks. We're going to repeat it now, cutting it in half, just folding everything in half. Okay, repeating that process now with a scale factor of 1/2. I just measure that distance, mark it on my index card, and as I mark it on my index card, I'm just going to fold that index card so that the corner matches up to here so that I can see where that halfway point is going to be. I'm going to estimate that it's right here. I don't know for sure if it is because of my issues with technology. That's how you'll do it. You'll measure it with your index card. You'll fold it in half. I'm going to switch gears, and I'm actually going to use my ruler now so that I can have mine precise. So from the center to this first point is 5.7. What I'm going to do is in my calculator, I'm going to type in 5.7 times 1/2. That's going to be a distance of 2.85. So I'm going to find that mark on my centimeter. On my centimeter ruler, 2.85 is going to be right around here. And that's going to be my first point. So again, if you would like to use your centimeter ruler, you can. If you want to continue using your index card or a scratch piece of paper to measure, you can do that. Looks like this one is 7.7. So 7.7 in my calculator times 1/2 is 3.85. .3. This distance for me is 6.3. 6.3 times 0.5 or 1/2 in my calculator is 3.15. And a distance of 4.4. 4.4 multiplied by 1/2 is 2.2. Now I'm ready to connect all of those, and hopefully all of my lines still appear to be parallel to the original figure. Looks okay, mostly okay. Okay, that's it for this video. The rest of what you see on this packet is going to be homework, so continue working. You're going to see that number 4 on the back side is a lot like problem number 1. Number 5 on the back side is a lot like problem number 2. And number 6 on the back side is a lot like problem number 3. So those will be your homework. Use class time to get them done. That's it for today. Thanks for watching. We'll see you next time.